We have Mary who's given the diagram below showing an angle of rotation of 120 degrees, which is lovely. But if we want to use the theta equals A over R formula, what do we need? Radians. So what's 120 in radians? Yeah, it'd be 2 pi over 3 because we go 120 times pi over 180, which equals 120 pi over 180, which is 2 pi over 3. So it says the radius of the circle to the nearest centimeter is 19. So we would have to find the radius first. So if theta equals A over R, these would swap out. R would equal A over theta. So it's A, which is 40, over theta, which is 2 pi over 3, not 120. And what do you get? 19. So is that true? Yeah. Then the equivalent angle of rotation is 4 pi over 3. Is that true? No. Now you have to watch. Sometimes they'll give you a coterminal with it, which would be true, right? If they give you a coterminal with 2 pi over 3, it would be fine. This one is not. Then this one says, if the arc length in the circle increases to 80 centimeters, so it doubles, then the central angle must be 240. Is that true? Yeah, because if this is 240 and another, this would be 240, which would be, or 120 and 120 would be 240. If you don't know, you could just use that as your arc length, use your radius of 19, solve for your theta, right, which would be in radians, convert to degrees, and it'll be 240. It will show you that it actually works. You can do that as well. Mary can determine the radius of the circle by dividing the given angle by the arc length. Is that true? No, she's doing the arc length divided by the given angle, correct? If you look here, arc length angle. This isn't true. So it says the two statements above that are correct. You have to watch because it could be false as well, right? So it's 1 and 3. If you gave 3, 1 in this case, you'd still be correct because it doesn't say respectively. Okay, we have root 3 over 2.5, and we have negative root 2 over 2 and root 2 over 2. Lie on the terminal arms, 2 different angles in standard position. So what is A at if it's root 3 over 2.5? 30. You can do these in degrees if you want to, or you can do them in radians, subtract them, it doesn't matter. So this would be 30, and this would be 135. Now if you subtract 135 from 30, or 30 from 135, you get 105, which is great, except they wanted expressed in radians, so we'd have to go 105 degrees to radians, pi on top, Dr. Pot. So we get 105, bless you, pi over 180, which reduces to? Now it says m, n, respectively. So 7, 1, 2 is how it would have to be. If you did 1, 2, 7, you would not get it. Right? Because it says respectively. So it has to be in the order m, then n. 7, 1, 2. This one here, this is the key thing you have to notice when reading this question. It says the point 0, point 2, and k lies on a circle. This is indirectly how they did it. They did it sneaky. On a circle with a center at the origin and a radius of 1. What is that a fancy way of saying? On the unit circle. So we know x squared plus y squared equals 1. And it says that it can be expressed as plus or minus root b, which means they didn't have to give us a quadrant, correct? Which is okay. So we're going to do y squared equals 1 minus 0.2 squared. So y squared equals what? 96, right? Square root plus or minus. Now this is where this question actually was done very poorly, because people will put the answer to root 0.96 to the nearest hundredth. They take the physical square root of it and give the answer. But you have to watch. It's plus or minus root b. b is what's underneath the root. It's 0.96. I see people do this on tests correctly all the time and then give the answer wrong because they square root the answer, right? But it's plus or minus root b. I want b. So don't square root it. So you have to pay attention because sometimes you guys will just get caught up on the way that they ask for the answer, which is just sad if that happens. Okay, this one you have to spot. It gives you a trig ratio. It gives you another trig ratio which limits the quadrant, correct? So we're going to draw our trig ratio, draw the angle, Draw a bow tie angle, find the third side, give the trig ratio. Every single time you see this, trig ratio, limited trig ratio. They can also ask for the rotational angle at this point, correct? But you could use any trig ratio you want, the positive version of that, get the reference angle, and then add to 180 in this case, I believe. Oh, no, not add to 180, subtract 180. Okay, so this one is sine is 7 over 10, sine is positive, tan is negative. Where the heck does that happen? Quadrant 2, so we're going to be here somewhere. Not the most accurate drawing because I literally just drew a line in there. But does it have to be, or are they marking us on our drawing? No. It does have to be in quadrant 2, though, because if they asked us for the rotational angle, we would have to know it's here, because we'll get a reference angle and subtract from 180 to get the rotation. Correct? We also need to know it's here to know if this is sign your resume. So we know now that our x is actually negative because it's here. Our y is 7, and our radius is 10. So x squared equals 10 squared minus 7 squared. X squared equals 100 minus 49. X squared equals 51. Square root, and we get plus or minus, but in this case, it's going to be negative root 51 because we drew it. If you don't draw it, you're 50-50 guessing, which is not where I want to be on a test. I want to be like, yes, this is what it is, use it. So this one, they want the value of x, it's negative root 51. Okay, what else could I have asked on this question? I want you to give me, I want tan theta. Do it. Give me tan theta. The trig ratio for tan theta. Tan your x box. Why would I pick this one? You have to rationalize the denominator because I'm kind like that. I want to make you do more. 7 over negative root 51. Nope, you can move it, yeah. Okay, so we would get negative 7 root 51 over 51. We agree? What if I ask you for the rotational angle? You can either use the tan one, or you could have used the sine. If you use the tan, you have to use the positive to get the reference angle. If you use the sine, you have to use the positive, but it already is. If I were a person who got to choose, and I was typing this into my calculator, would you pick sine or tan? Sine, because it's pretty. So let's do that. Pretty in, trig terms. I don't know if I hang it on my wall pretty, but, pretty for trig. So we have sine theta. If you come into my house, it's just trig ratio. It's like, oh, see, this is so pretty too. I just on my fridge of trig ratios. Yeah, trig ratio. So we have theta equals sine neg 1 of 7 over 10. Now, you can keep it in, when you go to press the sine button or the second sine button, you slap your hand and you're like, what mode do I need to be in? I'm going to do degree for now because I'm going to be kind, but this could be both, correct? So if we do degree, what do we get? 44 point what?
48.3.
Okay.
48.2.
Don't like you anymore, Alexa. She's on my do not ask list. 444.2. 3, 2, 1. 1, 2, 3. What the heck is bothering me? Her name starts with an A and she rhymes with Alexa. 44.4?
That's actually your favorite school.
Right.
I can't think of a
So that is my reference angle. That's not my rotational, correct? My rotational is from the x-axis to this terminal arm. It would be boom, 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 boom. So I would go 180 minus 44.4, which is 135.6. Because I just kept it as a 4. Okay? We're going to do a whole bunch of these today. That's what we're going to be doing. We're going to be solving for rotational angles. Yay! Okay, good. I'm glad. Glad you're all so excited. Okay, number 5. Use the following code to indicate that the value of the ratio is 0 or that the ratio is undefined. So tan of pi over 2. Don't go using your calculators. Use your brain cells. They're much more reliable, I promise. So tan your x box. At pi over 2, what's the your? 1. And what's the x? 0. What happens when you divide by 0? Undefined. Okay, cotan. Is tan your x box? So this is x box your. Shh. At 3 pi over 2, what's your x? 0. What's your y? What happens when you have 0 divided by negative 1? You get 0. Do not put a 0 here. It's a number 1. I get this answered wrong because you guys will put some weird... Then you'll be like, what do I put in for undefined? And I'm just like... Read question. Okay. Sine of pi. What is pi? What is y at pi? I feel like Dr. Seuss. It's 0. It can't be undefined, so please just pick 0. It just doesn't make any sense. So, it's 1. Because it's 0, and 0 is 1. Not because it's... Yeah. And then cosecant of 2 pi is sine flipped, right? It's 1 over sine of 2 pi. What is sine at 2 pi? 0. So it's undefined. If you don't remember that cosecant is 1 over sine, you have a formula sheet that will tell you so. It's lovely, right? Okay, I'm going to get you guys to flip to your notes. You're going to go to example 10 first. I know we're out of order. It's fine. I'm going to the easy ones first. Example 10. I chose example 10 first because if you look at all the answers on these ones, where are they directly off of? The unit circle. These are like the ones where you like throw a little party. You're like, thank you, unit circle. You're my friend. Okay, so here it says determine the angle. So what we've done up till now, except for when I gave you the trig ratio and made you find the rotational angle, is we found always answers. So I've given you an angle and asked for answers. I've given you like cos of pi or secant of 5 pi over 4, and you had to give me answers, correct? I gave you the angle. Today what we're going to do is I'm going to have the angle be an angle symbol, and I'm going to make you, that means you have to find it, okay? Now, on the unit circle, you can find numerous amounts of angles. They're lovely. They're great. 100% super fun, right? But what they can do on the test and what I can do on the test is I can restrict your domain to something other than the unit circle domain. Okay? So if we look here, look at how nice this one is. What is it? It's the unit circle domain. So I'm making you find that. So we're going to do that first, and then I'm going to restrict it to something different. Now, we know 1 over root 2 is just the same as what? Root 2 over 2. So this is the same as cos theta equals negative root 2 over 2, which is lovingly on our formula. No, it's not. It is on our unit circle. So cos is what on our unit circle? X. And where is x negative? Quadrants 2 and 3. So that's where I'm going to go look. I'm not going to go search the whole unit circle. That makes no sense. I'm going to go look for when x is negative root 2 over 2. We also know that root 2 over 2's happen at what angles? 45. So which ones did it happen at? Right here and right here, right? 135 and 225. So that would be my answer for this one as to what I gave you for restricted domain. And we would be done, and we would move on, and we would be happy. Life is good. So 20-1, honestly, the real 20-1, it just makes you restrict between 0 and 360. And then we get you to grade 12, and it's like, okay, now we're going to flip between any type of radians, any type of domain, and any type of degrees. Okay? Good. Like, it's just like we jump, and it doesn't have to be off your unit circle. So luckily, you were an AP, and they didn't just restrict to 0 and 360. You did radians and stuff. So you've looked at it before. So what if I go, I'm going to keep it in degrees, let's say, and I go from negative 360 is less than or equal to theta is less than or equal to 360. I still find it the same way, don't I? I still find the unit circle ones. the ones between 0 and 360, I just now have to do what to them? Minus 360, right? Minus 360 from them to get the coterminals that will fit, correct? So no matter what my restricted domain is, I don't really care what it is. I will always find the angles on my unit circle first, from 0 to 360, and then I just coterminal them. Then there's not a lot of brain matter needed. You just find the ones on 0 to 360 or 0 to 2 pi, then add 2 pi's or subtract 2 pi's, boom, boom, move on. That's it. Okay? So let's find the ones that would work with this. We're going to go theta equals 135 degrees minus 360, and we get negative 225. Good answer. Thank you. And then we do 225 minus 360, and we get negative 135. And if you remember, watch, if we go like this one is negative 135, and we go like this one is negative 225. So it does show that it works. Yes. Yeah. So our two answers, if I restricted my domain, would be these two. If I restricted it differently. Okay? You guys are going to do B. It's from 0 to 2 pi. So am I allowed to give answers in degrees? No, because my domain is in radians. If it's in radians, your answer must be in radians, or they will not accept it. And go. When you're done that will be here. I want you to go from negative 2 pi to 0. Try that out. Sine negative. Sine is what? Y. And where's y negative? So what are the answers? 4 pi over 3 and 5 pi over 3. So that would actually be the answer to this one. I'd go theta equals 4 pi over 3, 5 pi over 3. And the reason why I go theta equals is because I'm solving. And when I solve, you always have x equals, y equals, m equals, b equals. In this case, the variable is just theta equals. And you have to write the answers. Now, you could check these, right? Whenever you're solving, this is just solving with a fancy theta symbol. You could go sine of 4 pi over 3, but I'm putting in sine. I slap my hand and I go, what do I need to be in? Radians, because I'm going to put in radians. You're just checking if we were listening. So if we go sine of 4 pi over 3, we should get negative 0.8660, which is root 3 over 2. If we go sine of 5 pi over 3, we should get this. So every time you solve any of these, you can check them, right? You should be able to find out if you're right and be happy or wrong and go back. Okay? Now, the crappy thing is if you actually are right, but you put it in degree mode because you forget to check your mode. So when you touch the button, slap your hand, be like mode. Slap your hand mode. Like, don't be aggressive. Just a little tap is fine. Like, it doesn't need to be like bruised or something. Okay? Now, we want between negative 2 pi and 0. So we're going to go theta equals 4 pi over 3 minus 2 pi. Minusing 2 pi is the same as minusing 6 pi over 3. You get a common denominator. So I'm going to get negative 2 pi over 3. And then theta equals 5 pi over 3 minus 2 pi, which is actually just 6 pi over 3. And I get negative pi over 3. Do those make sense? Negative pi over 3? Yep. Negative 2 pi over 3? Yep. Okay? So those are good. All right. What about tan 1? Where does tan equal 1s? At the root 2 over 2, root 2 over 2, right? Because you have to do y divided by x, correct? And where in y are x the same? Because that's the only way you get a 1. Y and x are the same at all the 45s. I'm supposed to say 35s, so that's not true. At all the 45s. Where is tan positive? In quadrants 1 and 3. And if you look at the ones in quadrants 1 and 3, you have positive root 2 over 2, root 2 over 2, which would get you 1. This you'd have negative root 2 over 2 divided by negative root 2 over 2, which would get you 1. So your 45s are where the tans are equal to 1s, correct? So what's this one at? Pi over 4, and what's this one at? I find them on the unit circle between 0 and 2 pi no matter what, correct? Then I go from there and look at my actual domain. Okay, my domain is actually from negative pi to pi. So, does this one fit in pi? From 0 to pi? Yeah, from 0 to pi is that way. So this one's good. So theta equals pi over 4. I don't need to find its coterminal, because its coterminal, if I do the negative pi, is going to be way too big, isn't it? Because I would have to go from 0 to negative pi as well. So this one fits from 0 to negative pi. Problem is, 5 pi over 4 doesn't fit. But its coterminal will, because it'll be 0 to whatever we get here, correct? So 5 pi over 4 is too big for 0 to pi. Because this is from 0 to pi, technically, and then from negative pi to 0, correct? So this one fits from 0 to pi. This one won't fit from 0 to pi because it's too big. It won't fit from 0 to negative pi because it's the wrong angle, but its coterminal will. So if I go theta equals 5 pi over 4, subtract 2 pi, which is just the same as, I have to get a common denominator of 4. So I'm going to get 4 down here times by 4, 8 pi over 4, right? I will get negative 3 pi over 4. Negative 3 pi over 4 is to get me to here. Will that fit? Yeah, because it won't be as up to pi. So this one fits. So pi over 4 fits the 0 to pi, and then negative 3 pi over 4 fits the 0 to negative pi. Five pi over 4 is too big, right? Because it would be bigger than pi, so we can't count it, but we can count its coterminal. Yeah.
Isn't like pi and negative pi at the exact same spot?
They are at the same spot, but we're going to negative pi, so we can't count 5 pi over 4 because it's too big of an angle. But its coterminal angle, which goes this way, because negative pi is backwards. It's clockwise, right? So we can find this one's coterminal angle, which is negative 3 pi over 4, and that fits between negative pi and pi. It's a horizontal distance.
Does pi over 4 fit to negative pi?
Pi over 4 fits between 0 and pi.
Oh, okay.
Yeah, so we're there, in between where that theta actually is, exists the 0, right? So we technically have a number line here from negative pi to pi. In here is 0, correct? So between here and here is where pi over 4 fits, and between here and here is actually where negative 3 pi over 4 fits. Does that make sense? It's a horizontal distance between negative pi to pi. Cos of 0. That's asking me where? Technically x equals 0. Where is x equal to 0? Pi over 2 and 3 pi over 2. Now, could you do these all in degrees? Could you make this be negative 180 to 360? Make these be 90 and 270. Find the coterminals that fit because it makes more sense in your brain. Then convert to radians at the end? Yep. As long as you have the radian answer, you can do that. Some people will never ever exist in radians. Their life does not want to be there. And that's fine. You could do these in degrees, do these in degrees, do the coterminals in degrees, get them to match, and then convert to radians. But if you don't convert to radians at the end, you're in trouble. Because you need to have your answers in radians. So forever you want to exist. Honestly, it's easier not converting everything and then converting at the end, because then you're just doing so many steps. So, this is on the unit circle. This is from negative pi to 2 pi. Well, in here exists a 0. So 0 to 2 pi covers these two, correct? Does that make sense? So we know those are two answers, pi over 2 and then 3 pi over 2. And then we have to go from 0 to negative pi. 0 to negative pi, if I draw it, is from here to here, correct? What's the only answer that actually lands in there? The 3 pi over 2. We agree? But that's just the angle from 0 to 2 pi, correct? So we need to find its what? Its coterminal. Because this is the only one that would land in there. So all I have to do is find the coterminal of this baby, and I'm good. I got an answer. So let's do that. So it's going to be 3 pi over 2 minus 2 pi. Minusing 2 pi is the same as multiplied by 2 multiplied by 2. So it's be 3 pi over 2 minus 4 pi over 2, which is negative pi over 2. Now, does that make sense? To get to here, does that look like negative pi over 2? Yeah, subtracting a 90. So that's also an answer to this. That makes sense? Cotan theta equals root 3. Now is where life gets a little more rough. Okay? We don't have a cotan button. We agree? But we do have a tan. So we can go up here and we can say, what is cotan? Cotan is 1 over tan. Is that what it says? Right there? So cotan, instead of writing cotan, I could write 1 over tan theta. If it was in tan theta, would that make my life easier? Yeah. I have a tan theta down here and a root 3 up here. So can I divide the root 3 down and bring the tan theta up? Yep. So I can multiply by tan theta, and I can divide by root 3. So I'm going to get tan theta equals 1 over root 3. Which makes sense, because if this is root 3 over 1, if cotan theta equals root 3 over 1, tan theta equals its reciprocal, correct? This is x over y, this is y over x, right? They would just flip. And why do they flip? Because of this. Now, say we're stuck. I don't know where 1 over root 3 is. I'm stuck. I'm not sure where that is. Can I find its reference angle? Yeah? How do I do that? Theta equals tan neg 1. Do this in degrees to help you out. You have to do these ones in degrees because you're never going to get radians in exact values, correct? Like it's never going to say, oh, it's 2 pi over 3. It's going to give you a decimal answer. So always do them in degrees. So 1 over root 3. Always do the ones that you can't pull off the unit circle. Whenever you're doing tan neg 1, always put them in degrees. What do you get? 30? So that's the reference angle, which is lovely. But I need to have some arms to know to add 180, subtract 180, 360, minus it, or is it just in the answer? How do I do that? How do I get arms? The arms in the quadrants. What do we use? Yeah. Cast. Exactly. We've used cast rule. So we can get our reference theta. I'm going to write it as a reference angle. That's great. But then I need to use, that's always step 1. Step 2, I need to use cast. Or I don't have any arms. Well, I still have arms, but this doesn't have arms. So that was funny. No one laughed. Okay, good. Cotan or tan is what? Positive or negative? Because that's all we care about for cast. What's my answer? Is it positive or negative? It's positive. It's cotan theta equals positive, right? This is a positive. So I need to draw it in the positive tan angles. Where is tan positive? Here and here. And I'm drawing them like in 30s. Why am I drawing them at 30s? Because my reference angle is 30. So this one's going to be at 30. How do I find this one? How do I get to 30?
Oh.
I'm going to go 180 plus 30. So this one's at 210. Do we agree? This domain is from negative 180 to 180. We agree? Which fits? Just the 30 fits, correct? Does 210 fit? No. Does its coterminal fit? Yeah. Okay, so we can try these out. We can go theta equals 30. I can find this one's coterminal. I can go theta equals 30 minus 360. And I get negative 330. Did that one fit? I need to go from negative 180 to 180. That one's too big, right? So I'm going to draw a line through it. Then I have theta equals 210 is my other answer. Does that one fit? No, it's too big, so I'm going to draw a line through it. Then I'm going to try its coterminal. 210 minus 360 equals negative 150. Does that one fit? Yeah. What's my problem right now? It's in degrees. How do I convert to radians really quickly? Divide by 180, math, enter, add a pi, right? We do it for our unit circle the whole time. So this one's going to be pi over 6, and this one's going to be negative 5 pi over 6. And then I'm going to write it. You see how you can roll in degrees the whole time and just convert at the end? Yeah. A lot of people will make less mistakes that way. It's up to you how you do it. Okay? We're going to go down here to example 11. What's the problem with this? Is 0.876 on the unit circle? No. So when it's not on the unit circle, when Shane raised her hand, I'm like, what's the, oh yeah, thanks. So when it's not on the unit circle, you have to use the 3 steps. When it's on the unit circle, you can just draw them, find the coterminals. If it's not on the unit circle, you just did 3 steps and you didn't even realize it. Step 1, reference angle. Step 2, cast rule. Step 3, check coterminals. You did that every single time. So if you can't just find it off the unit circle, like if it's in root 3 over 2 or root 2 over 2 or a half or something like that, right? You can use the 3 steps. Now, could you use the 3 steps always? Yeah, even if it was on the unit circle, you could find the reference angle, cast rule, get answers. You don't ever have to go to your unit circle if you don't want to. It's just faster. So let's try this one out. What are the solutions between 0 and 360? Cos theta equals 0.876. So step 1, reference angle. Reference theta equals cos neg 1 of 0.876. Now, what if it was negative 0.876? It wouldn't matter. You'd still put in positive to get your reference angle. We're going to be in degree mode. On these, I always go in degree mode, just convert at the end. Degree mode, convert at the end. No, they'll say to the nearest tenth or something like that. I always just do to the tenth unless specified. So what do we get for an angle? 28.8. So that's my first one. Step 1, done. Yay. Step 2, cast. So I go up here and I say cos is it greater than 0 or less than 0? Greater than 0. So what is, cos theta, sorry. It's greater than 0. So that means I have to go work, C is positive, correct? Which is about here and about here. Right here and right here. So this one is the reference angle. Quadrant 1's great. It's like my best friend. I like it. It doesn't cause me problems ever. So theta equals 28.8 degrees. This is also theta. This is the theta reference. That's the theta reference, which is 28.8. How do I get this? Right. We want to get to here. So it's going to be 360 degrees minus 28.8 degrees. And what do I get? $330. It should be. Because 0.2 will get you to 9, then get you to 30. Do both of those fit? What is my domain? 0 to 360. Do they both fit?
Yes.
Yeah. If you get 0 to 360, you didn't realize how much fun that is. Like when you get 0 to 360 now, you're going to like throw a little party in your head being like, this is awesome. I like you. Okay. So our answer is going to be 28.8 degrees and 331.2 degrees. You guys try secant. What's the first thing I'm going to have to do with secant? Yeah, flip it. So you can write it as cos of 1/5, or if that's not how you roll, you can change secant to cos 1 over cos theta from off your formula sheet and flop them. Right? 5 comes down, cos comes up. And now do your 3 steps. Right? Cos comes up as multiplication, 5 comes down as division. So try this one out. All right. So if we cos neg 1, theta of 1/5, I'm going to do it in radians to prove that when these aren't on the unit circle, and when they're not nice degrees on the unit circle, it's often actually better. I don't know. You're probably going to convert them to degrees and convert them back to radians. I have like I try and push people not to do it that way, but it seems like everyone goes against my opinion and does degrees anyways and converts. So you know what? I'm just going to buckle to what you do. It's fine. So we're going to go second cos of 1/5. And it's 78.5 degrees. I'm assuming you did. Okay, this is from 0 to 360. Just so we know. Oh, wait, it's on the main one. Good. Right? Exciting when it's that one. Okay, so just so you know, if you're going to not have a nice decimal and you're going to convert, you're going to keep a few because you're going to have to convert back. Your decimal might be off a bit. There we go. Okay. So then we have to use cast rule. That's step 1. Step 2 is cast rule. Okay. I go here and I say secant theta is greater than 0. Secant goes with cos. So it's going to be here and here. It's 78. This one's going to be 78.46304097. And then this one's going to be 360 minus that, right? It's going to be like this. So it's going to be 281.5366959 degrees. Degrees to radians, what do we have to multiply by? Pi over 180. And you're going to actually multiply by pi over 180 in this case. You're not going to keep the pi on the top of a weird decimal. So you're going to take that answer above, times it by pi, divided by 180, and I get 1.4 grads. And then this one I'm going to take my 281 times by pi, divided by 180, and I get 4.9. There's like a rough spot on the board right there. Now, if you just did it in radians, you would get 1.4 here anyways, right? And then you'd go 2 pi minus 4.9 and get your, or minus 1.4, and you get 4.9. Okay, so theta is 1.4 and 4.9. Make sense? Yeah. You can box 2 places, but I always just put them together at the end. They're boxed in one answer. The person goes, they're like, this girl's a genius, or boy, because I can't tell. Most of the time you can by handwriting, but sometimes we're off, because sometimes girls write really bad, and sometimes boys write really nicely. But for the most part. They could read the what? No, we don't get to. Right? You're just a number to us when we're marking these. I could read the test name, sure. Anyways. So your homework is going to be, tomorrow we're doing degree 2. So we're going to do where they're actually like a quadratic. Then we just factor them, and we'll get 2 answers. We'll get like a sine of something and a cos of something. You did this last year. I know you did. And then we just end up doing this twice instead of once. Right? You just have to factor off. Yeah. Questions, page 211, numbers 1 and 4.